Alright, in this next tutorial what we're going to be trying to cover is to introduce you to the important concept of loops. We need to work with loops for the achievement standards, and it's also going to be really useful for solving a number of different problems that we've already faced, and some of the more interesting ones that we could be facing in the future. So in terms of our last exercise, some of the questions that or improvements that you could be adding to this program is continually asking the person's age until they get it within the correct boundaries. So for instance, if they enter in a number that's not valid, such as a negative number or above 120, it's going to keep repeating the question of saying how old are you. So to do that, we've got a number of ways which we can do it, but simply it's a conditional loop which is going to keep occurring until the person's typed in the correct answer. So we're going to go ahead and start a new program, but we're going to come back to this one here and try and adapt this and bring in a loop so that until they type in something valid, the question gets repeated. So let's go ahead and start a new project now. And this one here, I'll just call this one Introduction to Loops. Okay, so there's two main types of loops that we're going to be trying to focus on. The first of which is called a counted loop. A counted loop is used when we know exactly how many times that we'd like the loop to be run. It's got a little bit more writing involved with it, but it is a little bit safer in terms of the number of times it will run. One of the things that we don't want to occur with when we do a loop is for it to be stuck in an infinite loop. So a counted loop is a good way to work around those, so you don't have those problems. So to do a counted loop, when we know exactly how many times this might be, we use the keyword for, and then we need to have something that remembers how many times the loop is passed through. We call this passing through of a loop an iteration. So I'm going to use a variable called counter, and again at the top there it would be probably quite good to have declared the variable, which I'll go through and do that in a moment. Okay, so prior to this I probably should have gone through and declared this variable. So I'll call this counter, and it's going to be an integer, and I'm going to initialize it and give it a value of 0 to begin with. Down towards the actual loop syntax that I've written here, we've got a couple of keywords that are needed. We typed in the word for, we did a variable which is going to remember how many times it's gone through the loop, and then we say the number of times that we'd like the loop to run. So in this case it's going to run 10 times. Initially this variable counter has been given a value of 0, but in the first run through or pass through of this counted loop here, it's then assigned a value of 1. So after it's gone through the first time, it will hit this bottom next statement, and that tells it to jump back up to the top and to repeat whatever's in between these two lines. So the instructions that we'd like to try and repeat are going to be in between the for and the next statement. So to make this just a relatively simple program to show how this might work, I'm going to put the word hello inside of this box. Okay, and then after that I'm going to go through and do a console.readline. Now by doing this, it means that after each time it writes the word hello, there will be a pause where the focus is back on waiting for the user to push enter or some other key. Okay, so at the moment here's my program waiting, and then if I go and push any key on the keyboard and push enter, or just push the enter button, it will then go through into the second pass through of our loop. So at the moment, when it does the first hello, counter was set to 1, it does hello, it's done read line, it's done the pause, I pushed enter, it's now come up the top there, counter is being set to 2, and it's gone through and done the second hello. I'm going to push enter again, counter is now set to 3, 4, 5, 6, 7, 8, 9, 10. On the 10th time, counter is now equal to 10, so it will pop here one more time, and it'll realise that it's outside of that acceptable boundary. It will then jump out of the bottom here and then continue on with any additional code that you can see, therefore finishing the program. If I was to take out this console.readline and move this outside of the for next loop, that delay that we had before is no longer present, and all it does is simply outputs the word hello 10 times. To make this a little bit more meaningful, we can use concatenation to join on the contents of that variable onto each instance of the word hello. I'm just going to put a space here so there's a bit of a gap. Okay, and you can see the fact that we are looping through 10 times. Okay, so that is a counted loop. Counter loops also have a few other things that we can try and do with it. So in this case, if we wanted to add up all the numbers or show all of the numbers between 1 to 100, we can simply go through and then do this kind of thing. We can show make the number from the counter variable be displayed in the console, and here's all the numbers between 1 and 100 being outputted onto our form, in this case our console I should say. Another thing you could do if you wanted to remove the fact that it's doing an extra enter at the end of each of the lines is to make it use the console.write method. And what this does, instead of actually doing a character return or an enter, it will do the numbers directly after each other. So if I was to run this, it looks quite confusing, but you can see 1, 2, 3, 4, 5 all the way up to 10, then we've got 11, 12, etc. To make this a little bit more easy to see, we could again do some concatenation and place onto this a comma and then place a space character after that comma. If we go and run through this now, it becomes a little bit more easy to see what's happening. So you can see all the numbers between 1 and 100 are being outputted. Another thing that can be quite useful with any of these types of loops is if we're wanting to show all of the odd numbers or even numbers between 1 and 100. So if we were to do this with pen and paper, that would take us quite a lot of time. However, one of the nice things that we can do with a counted loop is that we can use something called the step function. A step function tells it how much to increment or increase between each cycle. So the way that you're going to write this is the keyword step, and then you tell it the way to jump this counter variable up. So to start with, it's going to be equal to 1. It's going to pass through the loop to start with, and then when it pops up the top again, it's going to have 2 added to it, so counter will be equal to 3 to begin with. So this will do all the odd numbers between 1 and 100, so 1, 3, 5, 7, etc., all the way through to 99. If I was to wanting to try and work with all the even numbers, we simply would change this to either 2 or down to 0 if we're wanting to include 0. Okay, so there we are, 0 all the way through to 100. Okay, so some quite useful ways of being able to work with the step function. Other things or variations that you might want to do is you might want to try and reverse that and do like a countdown clock. So you might decide to do a countdown from 20 to simulate a rocket taking off or something. So we might decide to do step 1 to 0. Now in order to try and work through this, we'd need to use a step function, but instead of increasing, we're going to decrease, which is called a decrement. Okay, so we're going to step by a -2 value, or -1 value I should say. By doing that, it means it will go 20, 19, 18, all the way down to 0. You can see here 20 down to 0. Same thing, if we're wanting to drop down in intervals of 2 or 3 or some other value, we simply change the negative number. Okay, so we'll be reducing down as so on. Okay, and remember that this is going to be the lower boundary. These can also be negative numbers if we wanted to go to a lower number, so we can actually go past into negatives if needed. Okay, so that's pretty much the counted loop, which is used whenever we're unsure, if we're sure of how many instances we would like the loop to run. So I'm going to go through and comment that stuff out. After going through and adding some of these XML comments, I'm going to add created by and the author date information. So now that we've got the author, purpose and the created dates, we're going to just get into the good habits of declaring and initializing and then also commenting some of these big blocks of code. So if I've got some additional variables here, I might decide to declare and initialize my variables and then go through and comment those out. Okay. Now a good practice to do is to actually go through and use these comments to provide a little bit of clarification for you. We don't have textbooks as such in our subject, but one of the things that we can do is to actually add some of our notes and comments and problems or things that you'd like to remember through the likes of these commenting areas. Okay, so even though it's clear to other people, what's going on. You might like to just provide a little bit of clarification to yourself, so further down the track in a few weeks time, if you want to go back and review some of your material, you can go through, take a look at some of this stuff here. So we might want to say here that a for loop is used when we know how many times to run the loop. And then we could also put the fact that step function can increase and decrease the interval. Of loop steps. Okay, so remember that's the parts in between the bit, in between the for and the next, that is going to get repeated. Code that gets repeated. And outputted. Okay, so what I'm going to do now is I'm going to comment all of the stuff out here apart from this top line, because I'm going to use that for our second loop that we've got. So the second loop that we've got is called a conditional loop, or a sentinel loop. A sentinel is like a guard, or someone that's kind of patrolling the boundaries. So a conditional or a sentinel loop is where we've got a condition that needs to be met in order for the loop to be occurring. So there's different ways that we can actually check on whether a loop should run at all or not. We can either decide to check at the start of a loop whether the loop should even run one time, or we can check at the end of the loop to see whether it should continue again. And I'm going to focus on checking at the start, and some of the loops that we've got is called a while or do while loop, and the syntax or the way that we write this is by putting the word while a condition is considered true or false. So at the moment we've got our counter variable being set to 0, and while the counter's variable is less than 100, I'd like to go through and do some stuff. Okay, so the stuff that we did previously was to output all the numbers between 1 and 100. We're going to go through and do the same thing. So while the counter is less than 100, which in this case it's set to 0, so it definitely is, we're going to go through and output some stuff onto the page. And again we're going to go through and output this counter variable, and we're going to then try and run through the program and see how things occur. Okay, so it's going to output the counter every time all the way through to 100. So let's go and test this program and see how she works. Okay, what's actually happening here is we've got a whole bunch of zeros occurring. This program is stuck in an infinite loop. At the moment, if I was to try and bring this up towards the middle and then release, it's going to keep popping down towards the bottom. That's because the loop is still running. This is now pages and pages long. The code's still continually running. One of the disadvantages or tricky things to do with working with a conditional loop is that we can get stuck in an infinite loop, which in programming terms is quite a bad thing. We need a way of checking to make sure that our program is incrementing, and also a way of being able to exit our loop so that that doesn't occur. So the problem that we've got is that up in the counter loop, it's automatically being incremented through this counter variable. It goes through and either counts up or counts down until it hits these outer boundaries. The do while or while loop does not have that same luxury. Instead, what we need to do is we need to manually increment this counter variable up or down until it meets our requirements. So for instance, one of the ways that we can do that is by manually incrementing our counter variable. So after each pass through or iteration of our loop, it's going to go through and make our counter variable get one bigger. Two ways of doing that. You can either do it the longhand way, which is whatever counter was to start with, add on 1 to it and then remember it as its new self. So for instance, if counter was equal to 0 to start with, it will go through while 0 is less than 100, yes it is, go through and do the stuff, output the number 0 to our page. 0 is equal to 0 plus 1, which is going to be equal 1. 1 is then stored in the variable counter, and then the loop is then rerun, and it's going to keep passing through. So let's go through and test that to see how she looks. And you can see here, one of the things that we need, of course, is going to be a console.readline. We didn't need that before because being stuck in an infinite loop, we never saw the end of the cycle occurring. You can see now that we're down to 99, not 100, as you might expect, and that is because of the way that we've done our operator here. If we wanted to actually include 100, we've got two choices. We could go through and put less than 101, or probably a bit more elegantly and more efficient is to go through and say if it's less than or equal to. So if it's less than or equal to 100, there you go, it's now going to be displaying onto the page all the way from 0 to 100. Okay, so if I wanted to make sure that it goes from 1 to 100, I would need to give that a different starting number, and now that's going to be working as expected. Okay, so that's going to be a conditional loop that's going to occur. Now if we wanted to go through and do the same things as we did before, where we're wanting to jump up and do all of the odd numbers, because we've set our initial variable to be 1, what we could do is just do a manual increment and jump up in intervals of 2. Now if you run that, you'll go through and see that it's jumping up and doing all the odd numbers. To make that do all the even numbers, taking this back to an even number to start with, leaving that as 2, would then go through and show 2 all the way through to 100. Same situation if we're wanting to not have the carriage return or the enter being pushed, we'd simply change that out back to a right, and then we'd do the extra concatenation to join that stuff on at the very end of it. Okay, so here we go, give that a go, and there's our numbers being output like so. Another useful thing for when we start using loops is when you want to do some math problems. A classic example might be if you're wanting to display the outputs of a bunch of numbers like in a spreadsheet. So if we were to go through and show a spreadsheet and then do a bunch of numbers and say let's add all those numbers together, what would they be? So you might be able to do that quickly in your head, but using the auto sum we should be getting an answer of 55. Now obviously using a program to do that rather than trying to do that manually ourselves is going to be much faster, and this is the kind of stuff that programming languages love to do. Programming can be a good way of solving some of these math problems through the use of loops. Okay, so that's relatively simple to do maybe in your head, but when we start wanting to do all the numbers between 1 and 100, that can be quite a lot more challenging. Okay, so if we were to try and work that out and say how far does that go down, what is that going to work through as? Okay, so there's all the numbers between 1 and 100, and then if we try and sum those numbers, okay, it should equal 50/50 if we've done this correctly. Okay, so there are two exercises that we're going to go through and check on now through the likes of using loops. The first of which we'll do using a counted loop, and the second of which we'll do using a conditional loop. Okay, so we're going to comment those out. Okay, not keep them. Okay, you might like to add some additional comments there to explain some of the things that I've talked about here tonight. Okay, and the next thing that we're going to do is go through and do our counted loop to begin with. So again, we can still use that same variable, because every time we run through, even if that was still there, it's going to get reset after it does this first bit of code here. So we're going to go through and add all of the numbers between 1 and 10 together. The next thing that we're wanting to do is we're not going to simply output the counter variable onto the page. We need to be able to remember what the counter plus the next counter is going to be. So we're going to need to know another variable, and this variable I'm going to declare and call total, and it's going to be an integer because all the whole round counting numbers added together will also be an integer. Okay, so inside of this we're now going to make this variable remember what it used to be. Okay, so on the first pass through of this counted loop, counter is going to be equal to 1, total is going to be equal to 0. So what we're going to do here is we're going to remember whatever total used to be. So for instance, if it used to equal 6 and it's going to come through and do this counter, we need to be able to remember 6 plus the next counter as it works its way through all the way up to 10. So we can do this by doing a little bit of simple math to say that whatever total used to be, remember it, and then add on the counter. Okay, so total plus equals total plus counter. Okay, so if we go through and run this program here, okay, one very important step missing, of course, and that is going to be our console.writeLine, and we're going to need to look at outputting the final answer. If we wanted to, we could go through and actually specify and show the logic of our program working each time, but in this case all I'm going to do is simply run the program and then show that 55 is matching our expected answer there before. Now the good thing about this is that we've done all the hard work now, and if we wanted to go through and show how we can solve this problem using a counter loop all the way up to 100, we simply change that to 100, rerun, and we get our 50-50, which is the same as you can see down the bottom there. Okay, so you can see that if we wanted to expand that up and do 1 to 1000, same logic applies. We can start doing this quite quickly. In maths, this kind of stuff can take quite a long time. There are some quite complicated formulas to try and work this kind of procedure out, but you can see in programming very fast to try and work through. Okay, so another way of trying to present this, rather than doing the total equals total plus counter and that you've got here, is you can simply go through and do it the shorthand way, which is total plus equals counter. This means basically whatever total used to be, remember it, and then add on counter afterwards. Okay, so at the top here we could do the same thing. We could do plus equals, and that would do the same thing as we had just before. It's going to remember what we had, and it's going to be looking to add on to it. Okay, so in this case we're going to be remembering counter, and we're wanting to add on to it 2. So 2 would be added on to our counter each time. If we're wanting to do a decrement or make things bigger or smaller I should say, we can do other types of shorthand ways. This would actually take 2 away from our counter each time through. We can do multiplication, we can do division. There's a whole bunch of other shorthand ways that we can try and work with, rather than trying to do them in the longhand way which we had before. It doesn't really matter which way you prefer, both of them will still allow you to go through and work towards gaining excellence. Alright, so that's looking to solve the problem that we just mentioned using a counter loop. Let's go through now and try and solve the same problem using a conditional loop. Okay, so comment those out, and we're now going to solve the same problem using a conditional loop. So while our counter at the moment is going to be equal to 0, I'll change this shortly. Okay, again I could have just left that, well I did just leave that even though it said 2 across the top there, because as soon as it hits that it's going to reinitialize and give it a new value of 1. Down towards the bottom, however, I did need to take that back to 0 because it doesn't do the same process down here. I could have gone through and actually reset that if I wanted to, rather than doing it just one time at the top, and because of sequence, as it runs through the codes, it's now reset that. But because there's nothing else that's using it now, because it's all been commented out, I'm going to go through and run this through. Okay, so while the counter is less than or equal to 10, let's go through and perform our calculations. So we can pretty much use that same situation here, where we're going to use total is equal to total plus counter. And remember, the other thing that we need to do in here is to actually manually increment our counter up. Okay, so if we don't do that, we're going to get stuck in our infinite loop, and the answer is not going to occur. Okay, and the last thing that we need is this line of code to make sure that we're actually getting our total outputted to the form or the console. Okay, so here's our 55 occurring. Again, if we wanted to change that all the way up to our 100, relatively simple to do that. Okay, there's our 50-50 occurring. Now, this particular loop here is always going to be running, well actually this kind of loop can actually run never, depending on the condition. For instance, if we were to try and have the loop structured in such a way that this would never run, that might be a little bit of a problem for the logic of our program. For instance, if the program was to ask, like we did in our previous example, of what's your age, and the person was to type in 120 years of age or 121, and then we only wanted to complete a loop if the person enters an age that is less than 121, okay, this loop would never run. So while the person's age is less than 121, which it isn't, let's do some stuff. So in this situation, the loop would just be skipped over completely. Let's just test that. We're going to do it a couple of ways. I'll try running the program to start with, and you'll notice nothing's going to occur. The reason why 0 is actually appearing is because of this total equals 0. Down towards the bottom there, it does actually tell it to output. Okay, but nothing else is actually happening. Another way of checking that logic is to go through and place a breakpoint in the left hand side, run the program, and then you can actually test how the logic's working. So put my mouse over the top here of my counter, and counter at the moment is equaling 121 from up the top there. Push F10, it will skip through the code. These two lines of code have been skipped because that condition's not met, so it will pop out the bottom and then continue on through the rest of my code. So what I'm trying to clarify or show here is that when we test at the beginning of our while loop for our condition, it means that the loop may never occur any time. Another way of trying to do a loop is if we want the loop to occur at least one time, and that is where we sometimes want to test at the bottom of our loop. A good analogy of this is when I try and teach my kids how to cross the road. If I go to a road and try and show to hold hands and then cross the road safely, I want to make sure that I don't cross the road if there are any cars coming. In this situation, I would want to be testing at the beginning of the loop. While there are no cars coming, it is safe to cross the road. So I would want to be testing that at the beginning. The wrong way to be doing that is to go through and complete the loop at least one time, which is cross the road and then check to see if the road is clear, which is obviously not the right way. If it was like a motorway, that could be a real problem because chances are you're going to get hit. So what we can do if we're wanting to test to the end of the condition is we can do something called a do while. And we're just going to have to try and change this a little bit around. Okay, so we're going to do a loop while a certain condition is considered true. I'm using the conditional check here. So this is how you can actually do a loop at least one time. So sometimes you want to do at least something at least one time inside of a loop, and at the bottom here we're going to do the check. Okay, so in this case I'm going to do the same situation that I've got at the top there. I'm going to try and run it through, and when we ran this last time it actually occurred and came up with an answer of 0. Let's count across the top. It's got 121. Okay, so we've got 121 for the counter. Count in total, which is going to be equal to 0. Okay, so 0 plus 121 is obviously going to be equal to 121, which is why that you can see it being outputted down towards the bottom there. So if we run that code through again, there's our outputted answer occurring. So if you want to have a loop run at least one time, you can do a loop check at the end. So that's going to be our initial introduction to loops, and we'll go through and try and expand on some of those previous examples using these ideas.